If we want to understand how the solar panels on the top of our roof works, we first have to understand that there are two important factors that make electricity generation from solar energy possible. These two factors are firstly the nature of the light that the sun emits, secondly the material with which solar panels are made. When light is emitted from the sun, it travels in discrete packets of energy called photons. Photons can be thought of as quanta of electromagnetic radiation. Photons have been represented in this presentation as glowing balls of energy. The second thing that makes solar power generation possible is the material with which solar cells are made. Solar cells are basically semiconductor devices, and silicon is one of the elements that is most commonly used in solar cells. Looking at the silicon atom, we find that it is a group 14 element on the periodic table and therefore has 14 electrons orbiting 14 protons. But what is of even more importance is that it has 4 valence electrons, and it is these valence electrons which will participate in reactions. It is these valence electrons that will play a role in setting up a semiconductor device. If we compare this to an atom with 3 valence electrons, or rather a trivalent atom such as boron, we find that it has 1 less electron to offer in a covalent bond with silicon. The fact that there is 1 less electron means that 1 more electron is required to form a stable covalent bond. Adding a trivalent element to silicon therefore makes it more positively charged and therefore more likely to accept electrons. This lack of a 4th electron can be thought of as a hole. Therefore, holes are positively charged and have a tendency to accept electrons. So a material that has an abundance of holes and positive charge is called a p-type material. Now, let us look at an element which has 5 valence electrons, or rather a pentavalent atom. It offers 1 extra electron in a covalent bond with silicon. The extra electrons cause the material to become negatively charged and have a tendency to donate electrons. Such a material with an abundance of negative charge and electrons free to react can be called an n-type material. If we bring an n-type material in contact with a p-type material, the negatively charged free electrons will be attracted to the positively charged holes, which will result in electrons moving towards the p-type, and holes will begin to move towards the n-type material. This flow or movement of holes and electrons continues until an electric field builds up. So once an electric field builds up, the holes and electrons do not have enough energy to overcome the electric field and they cannot move into this region. This region in which electrons have moved from the n-type material to the p-type material, and the holes have moved from the p-type material to the n-type material. This region in which an electric field has built up is called the depletion region, and this type of semiconductor setup is called an NP semiconductor. Once the photons that were introduced earlier strike the depletion region of the PN semiconductor, they introduce enough energy to overcome the electric field, which is preventing the further movement of charge carriers, and enough energy to free the electrons in the depletion region. These free electrons are then attracted towards the holes on the n-type side, and the n-type side then has an excess of negative charge, and the p-type has an excess of positive charge. And the opposite charge on each end creates electric potential. And once a conductor is used to connect both ends, a flow of electrons occurs, thus creating a flow of charge and therefore electricity. Now this is a small amount of electricity because we have only looked at one cell. But one solar panel is made up of multiple cells connected in parallel and series to produce the required level of current and voltage. Now we have a flow of charge through a semiconductor, which allows us to power our devices. Keep in mind that we have been looking at a single solar cell, but to generate more electricity, these cells are combined to form a solar panel, and the solar panels are combined to form a solar array. The solar array produces DC current, which can be stored in batteries. However, household appliances normally use AC current, so a DC to AC inverter will be used in this case. And that's it for how solar panels work. Thank you.